Example number 3, we want to determine the surface area of this cone. Not a contextual problem, so we don't need a contextual answer, but we still have to come up with a solution. We have a cone that has a radius of 33 inches and a height of 44 inches. We need to figure out, firstly, when we're trying to do surface area, what is the slant height? Okay, and we need to do that because our formula for the surface area of a cone, the surface area is equal to pi r squared plus pi rs. So we need to know what is our slant height. To do the slant height, we're going to use Pythagorean theorem. Okay, we think of it as A, B, and C, or R, H, and S, if you so choose. And so we are going to use Pythagorean theorem to find the slant height of our cone. All right, I'm going to use the radius as A, so I'm going to do 33 inches squared plus 44 inches squared. Just got to put that in brackets because it's not an area. There we go. Is equal to C. Well, here we're actually going to do S squared because we're looking for the slant height. All right, so we're going to do 33 squared plus 55, or sorry, not 55 squared, 44 squared. And this equals 3025 inches squared. When we put it together, is equal to S squared. Now again, you used Pythagorean theorem in the past, and we remember that to get our S all by itself, we need to take the square root of that side and the square root of this side right here. So to do that, well, we take the square root, and the square root of 3025 is 55, and that's going to be equal to the square root of S squared, which is S. So that tells us that this side length right here is 55 inches. All right, 33, 44, 55. This is our classic 3, 4, 5 Pythagorean theorem, or Pythagorean triple, which we'll get into when we hit trigonometry. We won't worry about that right now. All right, now we have our slant height. We also have our radius. We can find the surface area of our cone. Radius, 33 inches squared plus pi times radius, 33 inches, times the slant height, 55 inches. And we're going to get a really nice big number in this case here. Some people, and some students especially, are scared of big numbers. I hope that you are not, because we will definitely be using big numbers in this course here. And we get a number of 9123.19 inches squared. Okay, 9,129.19 inches squared. We're dealing with big numbers while we're multiplying, so we're going to end up getting a pretty big number when we do all the calculations. Okay, this is the total surface area of our cone. That includes the lateral area and the base. Now let's take a look at a second example. We have a roof being built. Oh, wait a minute, we got context. So it's important to remember we got context. We have a roof is built in the shape of a cone which has a height of 14 feet and a diameter of 20 feet. Find the area of the roof which will be shingled. Well, we have to think about context here. And context is super important when it comes to these questions, because if we don't include the context, okay, we might not know what we are asked to do. Okay, so I'm going to design my, here I have my roof. Here's the height, and here is the diameter. There we go, that looks pretty good. Let's put our measurements that we have in there. We have a height of 14 feet. And we have, I'll do it on the bottom here, a diameter of 20 feet. There we go, put it in there. We have a height of 14 feet, we have a diameter of 20 feet. Well, we want to try to find the area that's going to be shingled. A roof only gets shingled on top. We don't shingle underneath, we just shingle on top. So we're just going to be needing the lateral area. So what that should tell us right away is that with our equation, we only need the pi rs part. We just need our lateral area in here. So we need our slant height and we need our radius. Firstly, we have our diameter and our height. So we don't even know what our radius or our slant height is. Let's start off by getting the radius. That part is fairly straightforward. We divide our diameter by 2, and so we get a radius is equal to 10 feet. Okay, so our radius is equal to 10 feet, we've got that. Then we need to do our slant height. Well, for that, we need to do Pythagorean theorem again. Smooth that up just a hair there. All right, so we need to find, using Pythagorean theorem, what is our slant height. All right, radius will be our A, height will be our B, and then our slant height will be our C. And so I'm going to put that in there with 10 feet. You put squared plus 14 feet squared is equal to our S squared, and that is our slant height. So 10 squared plus 14 squared gives us 296 feet squared is equal to S squared. Okay. Now, I'm not overly concerned about you having the units in this part here. Make sure you have your units at the end. And anytime you're labeling anything, make sure that you're putting units in there. Take the square root of both. The square root of 296 is 17.20. So we have 17.20 feet is equal to S, and that is our slant height. And I'm going to put that in here right away. 17.20 feet is our slant height. All right, now we have our slant height and we have our radius. So we can go back and we can solve for our surface or our lateral area of the shingled, or at least the shingled area. So surface area is equal to pi times the radius, 10 feet, times the slant height, 17.20 feet. And we're going to get a surface area or a lateral area of pi times 10 times 17.2, 540.35 feet squared. This is our surface area of our shingle. So what we can say here, and again, we're always going to put everything to 2 decimal places when at all possible, or unless it asks otherwise. So now we're going to say that the area of the roof which needs to be shingled is 540.35 feet squared. Now you'll notice how I've used feet here instead of the little apostrophe, and that totally works. You can do it either or. Again, I use feet here because I'm squaring it. Sometimes it looks a little neater than using the apostrophe and squaring it. So make sure you know what you're dealing with. If you have context, you need to know, are you doing the whole thing or just the lateral area? Or even in a regular one, if it asks for lateral area, we just do this. If we're asked for the whole thing, then we use the entire formula for a cone. Now, a reminder, your formulas for a cone, you have it right here. Surface area is equal to pi r squared plus pi rs. This is in your formula sheet, so you have that there, and I've given you a diagram for it as well. And finally, your assignment, finish up questions 4, 5, 7, and 8b, and those all deal with cones, both lateral area and the entire cone.